The first fast radio burst to be discovered in the Milky Way has been traced back to a magnetar known as SGR 1935+2154, located 32,616 light-years away from Earth, astronomers researching the phenomena told Nature magazine. The burst was detected by satellites including NASA's Neil Gehrels Swift Observatory and radio telescopes operated by the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, and the Survey for Transient Astronomical Radio Emission 2, or STARE-2 in the US. Fast radio bursts are brief but cataclysmic high-energy blasts that flare for just milliseconds but release as much energy as our sun generates in 80 years, according to previous findings published in Nature. A magnetar is described in the Annual Review of Astronomy and Astrophysics as a kind of highly magnetized neutron star, the compressed core of a star that exploded in a supernova and collapsed in on itself. According to NASA, a magnetar is roughly 20 kilometers in diameter and is so dense that a single tablespoon of its mass could weigh 1 billion tons. It rotates faster than ordinary neutron stars, once in less than 1 second. Magnetars are surrounded by intense magnetic fields. Citing University of Toronto astronomer and CHIME member Paul Schultz, Nature magazine explains that because they spin so quickly, magnetars built up huge reservoirs of energy that could produce powerful cosmic blasts. According to one theory, magnetars might be able to power fast radio bursts by releasing flares of energy in a starquake caused by the huge stresses exerted on the magnetar as its magnetic fields twist and snap back in place. I wouldn't say it's the nail in the coffin that we've figured out that fast radio bursts come from magnetars, Emily Petrov, an astronomer at the University of Amsterdam, told Nature magazine, but it's by far the most promising piece of evidence that we've found. A neutron star is the remnants of a star whose mass ranges from 1 to 3 solar masses. But what happens when an even bigger star collapses? It can form a black hole. Astronomers think they have found the universe's nearest black hole to Earth. But what's so remarkable about it besides being close, you ask? Well, you see, our neighborhood black hole is, so to speak, a vegetarian among black holes. Scientists at the European Southern Observatory report they may have spotted a black hole so close to Earth that its 2 companion stars are visible to the naked eye. According to the paper in Astronomy and Physics, the black hole is 1,000 light-years distant in the HR 6819 system, which is part of the constellation Telescopium. Writing in a news release, the scientists say a black hole is usually identified by the accretion disk it forms as it devours a nearby star and the energy that it releases into space. However, the black hole of HR 6819 exists peacefully with its stellar companions, and astronomers use the orbits of the 2 stars to infer that an object with 4 times the solar mass is in the system, which can only be a black hole. Astronomers have discovered unusually rapid jets of plasma spewing from an extraordinary black hole in space. According to research published in the journal Nature, the V404 Cygni binary system, located 7,800 light-years from Earth, contains a black hole that feeds on a nearby star, with a material siphon circling the hole in the form of an accretion disk. Some of the particles that fall into the black hole escape via jets of plasma called relativistic jets that shoot from its poles. But while most jets shoot straight out, the jets of the V404 Cygni black hole shoot out rapidly in different directions and at different times. According to Einstein's theory of general relativity, a spinning black hole's gravitational field pulls space and time around with it, an effect called frame dragging. In V404 Cygni, the black hole and disk are misaligned, causing the frame dragging effect to warp the donut-shaped inner ring. This in turn causes it to wobble like a spinning top and fire jets out in different directions. Researchers from the International Center for Radio Astronomy Research say that since the black hole was moving so fast, the usual radio telescopes that rely on long exposure for imaging became useless. Instead, the team produced 103 individual images, each roughly 70 seconds long, that they then joined together into a movie. A magnetic field at the center of our galaxy may be keeping a supermassive black hole at bay. According to their website, NASA believe they now know why the supermassive black hole at the center of our galaxy is suspiciously dormant in comparison to others in different galaxies. New research from NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, is helping scientists understand the difference between a highly active black hole and a relatively inactive one. The results from SOFIA and its infrared camera, or HAWK Plus, have given them a large amount of data about the magnetic field at the center of the Milky Way and its role in making the Sagittarius A-star black hole so tranquil. NASA stated that, like most black holes, if the magnetic field funnels the gas directly into it, the black hole is active because of its mass consumption of gas. However, the new observations using HAWK Plus reveals that the magnetic field at the center of the Milky Way channels the gas so it flows into an orbit around the black hole, making the black hole calmer because it's not ingesting any gas that would ultimately create new stars. Principal investigator and lead author of the study, Darren Dowell, said, "The spiral shape of the magnetic field channels the gas into an orbit around the black hole. This could explain why our black hole is quiet while others are active." According to NASA, the new observations using HAWK Plus helps understand how the material in the atmosphere of a supermassive black hole interacts with its host, and also to help to answer why the black hole in the center of the Milky Way is fainter in comparison to those in other galaxies. The Metro reported that Sagittarius A-star is about 25,640 light-years away, so didn't really matter anyway.
Researchers are trying to make tiny wormhole analogues with quantum circuits. Scientists have proposed to build a functional wormhole tunnel by simulating quantum entangled black holes in a lab. Quantum magazine reports that linked black holes are theoretically able to teleport quantum information via the tunnel. Black holes were thought to totally obliterate objects they consume. However, the experiment will test a new idea in physics that evaporating black holes actually send information about subsumed objects back to the universe via Hawking radiation. Citing California Institute of Technology physicist Safir Nazimi, the outlet reports the research team believes a black hole could be forced to disgorge intact information after it is entangled with another black hole on a quantum level. Stanford University's Adam Brown is cited as saying quantum circuitry could make a functional analog for entangled black holes. If the theory is correct, this circuitry would be able to instantly transmit and decrypt qubits, also known as quantum teleportation.
Life Science reports that 2 independently published studies have called into question the size of the impossibly big black hole named LB1. A team led by Chinese astronomer Liu Jingfeng claimed that LB1 is 70 times the mass of the Sun, bigger than the 20 solar mass models predicted for black holes in our galaxy. 2 independent papers published through the archive database found the same basic problem with the Chinese researchers' claim. It relied on evidence that the unseen black hole was wiggling very slightly as its heavy companion star wheeled around it. The new studies claim that the initial team misinterpreted what they were seeing in the light from the distant system. Movements from LB1 create spectral light via Doppler effect called H-alpha line emissions. The team said they used China's powerful LaMost telescope to detect H-alpha line emissions, then used the black hole's movements to infer its mass. Live Science reports that authors of the new studies argued that the original team did not properly adjust for the emissions from LB1 star, which also emits H-alpha. Astrophysicists Al-Badri and Quatert write in their paper that after factoring in the star, the data suggests LB1 is far more likely to be a sun-sized black hole.
Scientists map out black holes' surroundings with cosmic echolocation. Astronomers have found a novel way to explore the regions around a black hole. In a paper published in Nature Astronomy, researchers say they were able to use X-ray echoes around a black hole to map the celestial body's surroundings. According to the University of Cambridge's news release, that black hole's gravitational force is extremely powerful and causes massive spatial distortions around itself. As objects caught in the black hole pool are drawn to the event horizon, they heat up and radiate X-rays that echo and reverberate against nearby gas. Using the European Space Agency's XMM X-ray Observatory, the team was able to observe X-ray echoes of a black hole at the heart of a distant galaxy. The echoes allowed the team to determine the spin and mass of the black hole. The team also made the unexpected discovery that a black hole's corona, or hot electrons above the accretion disk, changed its size often and quickly. By raising and lowering the roof of the cosmic echo chamber, the corona's shift in size affected the light echoes and changed their quality.
For more news animations and explainers, hit the subscribe and bell button to join the TomoNews family. Thanks for watching.